Hello and welcome to our fourth lesson on sound. I hope all of you are doing fine.
Yes, thank you.
Yes, I'm fine too. Thank you.
In the last lesson, we learnt the definition of frequency. Who can tell me the definition of frequency?
I can.
I can.
Okay, Devi, tell me.
Frequency is the number of waves completed per second.
And what is the SI unit of frequency, Joy?
It is hertz. If one wave is completed in 1 second, then the frequency of vibration is 1 hertz.
That's good, Devi and Joy. Well, today we want to learn what aspect of the sound we hear changes when frequency changes and what changes when amplitude changes. So let's look at frequency first. Look at this picture. The upper waveform has a higher frequency than the lower one. This is because the upper one completes a greater number of waves in 9 seconds than the lower one. In fact, the upper one completes 12 waves while the lower one completes 5 waves, both in a time of 9 seconds. So, the upper wave has a higher frequency than the lower one. The upper one has a frequency of 1.33 Hertz, while the lower one has a frequency of 0.56 Hertz. But these are waves that I have drawn to explain the idea of frequency. Let us now look at the wave patterns of some pure notes in the human audible range.
Really? Do they look different?
No, here you are. Look at this. This is a pure note. Pure notes have a single frequency in them. This one has a frequency of 220 Hertz. The x-axis shows time in seconds, and between the two yellow-orange lines, the time axis reads 0 to 0.050 seconds, and the y-axis shows amplitude. Let us listen to the pure note of frequency 220 Hertz. The highlighted portion shows one wave. We can calculate the frequency from the wave pattern also. There are 11 waves, as I said, completed in 0.050 seconds. Thus, its frequency is 11 divided by 0.050, which is 220 Hertz. Before we go on to the next pure note, let us listen to 220 Hertz again so that you can understand the difference in the notes. Let us play this note now. This is 440 Hertz. Children, do you notice the difference?
Yes, this is shriller.
Yes, this has a higher pitch.
Can we see how their waveforms compare?
Surely. Here you are. There are 22 waves completed in the same 0.50 seconds. So the frequency will also be exactly double. Let us play the two notes one after another again. Now, let us listen to two other notes, 800 Hertz and 1600 Hertz. In the upper waveform, there are 40 waves completed in 0.050 seconds, which means it has a frequency of 800 Hertz, and the lower waveform has 80 waves completed in the same 0.05 seconds, which means it has a frequency of 1600 Hertz. By now, you surely must have understood which quality of the sound we hear changes when frequency changes? Now, let us look at amplitude. Here, you can see two waveforms. Both have the same frequency of 220 Hz, as both complete 11 waves in 0.05 seconds. But the upper waveform has a smaller amplitude in comparison to that of the lower one. So, the question is, what aspect of a sound changes when we change its amplitude? Let us play the two pure notes. First, the upper one with the smaller amplitude. Now, let us listen to the waveform with the larger amplitude. So, what difference did you notice between the two sounds?
The second one was louder.
Yes, the second sound was louder than the first.
Now you understand the difference that amplitude makes to a sound? When you increase the volume of your TV or radio or mobile phone, you are actually increasing the amplitude of the sound. That is all we had set out to learn in this lesson. But before we wind up, a quick recap. As we increase the frequency of a wave, its dash increases.
Pitch increases.
Pitch increases.
That's right. And as we increase the amplitude of a wave, its dash increases.
Its loudness increases.
That's right. So I'll see you all again in the next lesson. Bye-bye.
Bye-bye,
Bye-bye, sir.